Good evening. My name is Mike Woodward, and this evening I'm going to talk about Cursor for code generation for data apps. I'm going to talk about the benefits, the opportunities, and some of the issues. Now, this session is split in two. The first 45 minutes we're going to go over the basics, and that will be done by me. And the next 45 minutes will be done by my colleague Sebastian, who's going to talk about the more advanced features of Cursor. Okay, let's dive straight in with this and talk about what Cursor is. It is an agentic IDE for code development. Now let's unpack that statement a little bit. It means that with Cursor you can create code, and you can create code in different languages. For example, you can create code in Python or JavaScript or other languages. You can edit code. Now that's fairly obvious, but what you can do is edit code quality things, like for example using PEP8 or using linters. You can create test code. In other words, you can go and create test harnesses. You can document your code, so you can ask Cursor to insert comments, Google-style function headings, and so on and so on. You can also use it to interrogate the code base. So for example, if there's some code that you haven't used in some time or some code that's new to you, you can ask Cursor to go and have a look at it, and then you can ask questions about it. So for example, explain how this code works, explain how this code does this, that, and the other. Now what this all means taken together is that you can automate a huge range of software development tasks. You can automate the boring stuff and the stuff that you don't want to do. As a result of this, it is a productivity multiplier. And as we'll see as we go through this session, there are things that would have taken days which can take place in minutes. Now that also enables you as a data scientist to focus on your value add and not get caught up so much in terms of some of the bureaucratic and low-level coding work that you would otherwise have to do. It frees you up to do your value-added stuff. So the goals of this session, of this 45 minutes, is to convince you to use AI code generation for data science. I'm going to show you what you can do, but I'm also going to show you the pitfalls. This is not a magic wand. All right, let's have a look at Cursor, and that's what you see on the screen in front of you. It is based on Visual Studio Code, so I'm not going to go and explain what all the various features are in front of you. I am going to focus on the most important piece, which is this piece on the right-hand side, which is the AI prompt. This is where we'll be entering stuff to prompt it to go and build stuff, to prompt it to go and create a prompt, and to go and edit it, to go and have a look at, maybe ask it some questions, or to document code. All of that takes place in this prompt here, where I'm typing the word prompt. Now, we can choose different AI engines in here. By default, I've just selected Cursor's native engine, but I could choose other AI code generation engines here. But be careful here, there can be cost implications if you choose to do that. Now, after the break, Sebastian will talk about the rules and agents. That's not something that I'm going to get involved in the basic stuff that we're going to talk about over the next 40 minutes or so. Okay. Let's start with a real example. What we're going to do is I'm going to show you using the prompt window, this thing on the right-hand side, to go and create code. And let's start with something fairly simple. There is a case in point that a number of data scientists have where they've created code in a notebook. And this notebook may well have various charts and may well have some inputs and documentation or whatever. And they want to put a UI on it to show their management. Now, I've had this experience. I know that many of you have had too as well. The problem is that to do so would take you perhaps a week's worth of effort to go and translate that notebook, put maybe a Streamlit UI on it or something like that, and have all the controls there and whatever. There's a lot of work. None of it is particularly difficult, but it just takes some time. What I'm going to do in this session is show you how you can put a UI on a notebook very quickly. So this is the notebook. It's on the screen right now. It is in Cursor. I'll just scroll through it. And we can see the notebook cells. We can see some model definitions. We can see some code. There's cells, some default parameters. There's a simulation function. So this fairly standard stuff. Oh, some code to go and visualize the results of the simulation and so on. And I'll scroll down and we'll see some charts at the bottom as well. Now this is all based on an SIRV model, which is susceptibility, infectious, recovered and vaccinated model. So very much inspired by the 6th anniversary of COVID, for those of you who remember COVID. This notebook has a bunch of input parameters. It does some calculations, there's some charts and some documentation. Right, so very, very typical data science notebook. It is not interactive. What we're going to do is put a Streamlit UI on this. Now, it's going to take 3.5 minutes, so I'm going to take a bit of a shortcut here. So I'm going to choose Open Folder. I am going to scroll down here, and I am going to go to the Epidemic Streamlit. And this is an empty notebook. What I'm going to do is go and load up a prompt. Sorry, I'm just remembering where it is. And I'm going to insert this prompt into the AI window. Let's go and create a new window. I'll explain why in a second. I'll put this prompt in. I'm actually going to suggest it's going to run in agent mode, which is immediate. So it's going to generate code immediately when I click on this, and I'll submit it running. Now, from experience, that takes about 3.5 minutes to run. So what I did is I went to a brand new folder and I had opened a new prompt window. That's a good thing to do. It's good practice, actually, if you've got some stuff lying around. If you put lots and lots of prompts in and you iterate round, as we'll see in a second, you can fill up the prompt window, fill up the context window, and it can be a little bit difficult to use. So we started from scratch here. I've given it a new prompt window. And let me go and find it. There is the prompt, and I'll read it out. The prompt is, open the project Epidemic Notebook, which is in a subfolder in the parent folder for this project. Convert the notebook to a Python file. Put a Streamlit front end on the code so the user can interact with the parameters and see the results in charts. Use Altair to plot the charts. Use the latest Streamlit functionality. Check all function arguments are of the correct form before running. Now I've inserted that here, and you can see it's going away. It's generating some code. It's created a git ignore here. That's the Streamlit prompt. Oh, I forgot, actually, we could have a look at that. I didn't need to go and open that in the separate browser, but anyway, it's here. And it's going through various steps to go and build this. Now, as I said, there are different modes here, and I'll just open up the window here. Agent mode, which is basically go away and build me this thing immediately. Plan mode, which we'll get on to next, which is go away and build me a prompt. Debug mode, which is exactly as it says it is. It helps you debug the code, and ask is you can ask questions about the code or more general questions. So what this is doing, I submitted the prompt here in agent mode and told it to go ahead and generate the code. It's generating the code. You can see here it's building it line by line. It's putting in arguments. It's putting in comments here. Now, you probably didn't see that as it flashed by, but it did actually open up a function, and it used Google doc style doc strings for that function, as we'll see. Okay, so there it is. It's built the model, and here it is. By the way, you can see the background here is all khaki. What it does is when it generates code and it creates something new, either at a function level or an entire file level or just at a few lines, it highlights the changed code in this light khaki color. And it's asking me if I want to keep it, which I do. So let's go and have a look at this code. So you can see it's Google style comments. I'll just scroll down. Now the code is fairly explicable here. There's not really that much that's very complicated. In a more complicated code base, it would actually give you some proper comments in the text. It's actually done a reasonable choice of variable names. As you can see, tspan params. So it's apart from SIRV, which it got from the notebook, it has generally speaking stayed away from single character names, which is good. And on the whole, it's actually done a decent job as I scroll through, as you can see what it's actually produced. Now, it's also doing a little bit of testing as well. So it is going away and having a little think about and testing that the arguments actually contain the correct parameters. So it's a little bit of troubleshooting itself. So it's not fully troubleshooting, just a little bit there, but it is doing it. It is doing a little bit of testing. So this is what we're going to do to develop now. We're going to take this generated code when it's finished. We're going to run it. We're going to look for some things that we want to change. We're going to prompt the AI to change things. And we're going to go through this kind of iteration cycle. So prompt, check, prompt, check, prompt, check, and so on. And it's still off building. Now this is going to take about 3.5 minutes in total from me putting the prompt in to run it. And as we'll see, it actually does run when it finishes. So the question that I am going to ask you is, how long would it take you to build a Streamlit interface to a notebook? So would it take you 2 days, 2 hours? Or would it take you 3.5 minutes? Now, almost certainly it would take you a lot longer than that. A lot longer than 3.5 minutes. Now, the code that it's produced, well, it's kind of okay. There's nothing wrong with it. But the point about this kind of code is it's inherently disposable, meaning that, if the code's trashed or it doesn't work entirely properly, or for example, maybe if it's a bit slow, nobody really cares. It's good enough to go and demonstrate that you've got a working system to your management, and you can go and show how the whole thing works. Right, now this seems to be in the process of doing some bits and pieces. What I will do is I'm going to ask it to run the app. Now, I could actually do this using the correct format, using the Streamlit code, but I'm actually going to ask the system to do it for me, to figure out how I need to run it. Now, it's still planning its next moves. There we go. So this is one of the issues with code generation, right? It does, unless what you're doing is really, really simple, it will take a little while to execute. So this is a typical kind of cycle here. Is often you go and engage with it, you set the prompt running, then you can go off, maybe have a cup of coffee or do something else while it sorts out what it needs to do, and then you come back and then check. Right, so this is like a call back to the old days where people used to sit back in their chair waiting for the system to compile. We've got something of that same flavor of compilation going on here as well. There we go. It looks as if it's completing some of the checks. There we go. And now it's giving me a summary of what it's done. It's used Altair charts. Oh, by the way, why did I choose Altair? Because Altair works very well with Streamlit. I tried to do it with Bokeh originally and it didn't work so well. So Altair works much more naturally with Streamlit. So I'll hit run. Now what this is going to do is it's going to figure out how to run the application. There we go. And as you can see on the screen, it's booting it up. And I'll just make my screen a little bit bigger here so you can see. On the left-hand side here is the inputs to the model. On the right-hand side is some of the key values. And there are some charts here showing the infected over time, the recovered, the susceptible and vaccinated. And then there's the phase diagram. Right, so it's the same kind of output that we saw with the notebook, but this time in an app. So I can do things. Let me just position myself a bit better. And I zoomed in on this chart when I didn't quite want to. I'm going to change the base transmission rate from 0.3 to 0.58. Okay, and you can see the charts updating and the numbers updated. I will change the recovery rate, make it a bit lower, and you can see how the whole system recalculates almost immediately. So imagine showing your manager this, right? They don't quite know what you're doing. You've built something in a notebook, and now you can demonstrate in a UI how the whole thing works. Now, I told you that we can iterate on this, so let's do that. So there are a number of things that we might want to change. I notice here that there's no virtual, there's a kind of sense of a virtual environment, but I'll get it to use it. and it's going to go away and change the code structure so that it's going to run from the virtual environment. And it's doing that. It's making some changes. By the way, it's going to create a README file at some point. Create project documentation in a readme.md file that explains how to run the software and what it is. Okay, so I'm going to click submit. Because I'm in agent mode, it's going to execute immediately. And there's the README file. It's going to update the existing README file, which we can have a look at in a minute. One thing I might want to do, and I noticed on the charts, is I set a population parameter of 10,000, which obviously you can change, and the charts show the population numbers. What I might want, in fact, what might be more meaningful, is to show the population as a fraction. So, for example, the infected, of the total population of the infected, what percentage are infected, recovered, vaccinated, and so on. So let me enter that here. Show chart. Let's create a new tab. Create a new tab for each chart. Chart. One tab shows the charts using the population on the y-axis. The other tab shows the numbers as a fraction of the population. So if the if the total population was 1,000 and the infected were 5,000, it would show as 0.5 on the chart. Now what it's going to do is it's going to look at it, think about what I've said, try to understand my English, correct any obvious spelling mistakes, and it will try to understand what it is that I want to do. It already noted that the R number, which is already a fraction, is not impacted by this change that I want to make, but this change does affect other charts as well. So it's trying to figure out which charts are actually affected and then what code it has to change to make that happen. It's then going to go away and rebuild the whole system, and it's going to put those changes in, and it's taking a while. It's going to make a tab per chart and with the subtabs, as we can see here. And when it's done that, when it's rebuilt it, what I'm going to do is I'm going to run it again so you can see this change. So we're getting into this idea of a cycle, a prompt review cycle over and over again. Now, okay, this looks like it's worked. So let me hit run. Okay, no, it's queued. It's thinking about making some other changes. So what's happened here is I have asked it to do another task when it hasn't finished the prior task. So it's queued up my new task in the queue. So I can ask it to do a number of other things here, and they will all be queued up pending the completion of the various tasks. So it doesn't run these tasks in parallel. It runs them sequentially one after the other. And what we'll see is when it's finished generating the new code, it will go and run the Streamlit model again. And we'll just wait for it to go off and complete. That's, by the way, that's one of the problems with presenting on this type of content, right? What happens is you're waiting for the system to basically go and generate code, which gives you some time to fill, right? And that's also the case as well. If you give it a more complicated prompt, as we'll see in the next demonstration after this, it just gets harder and harder, right? It takes longer and longer to go and build the system. So in some cases, I've seen it take 15 or 20 minutes to build a quite complex system involving lots of moving parts. So just be aware that the more complicated you make the system, the harder it is to go and build something, and the longer it's going to take to go and construct it. Okay, there we go. It's actually run the code, and population counts, there it is, fraction. So you can see there it is, same chart, but this time it's on the y-axis. Instead of it being 10,000, when I click to fraction of the population, it starts off as 1, and so on. And that's a similar for some of these fraction of the population, same thing. Cumulative cases in immunity, same thing. Right, so it's actually gone away and done this. I'm going to show you one last thing. Now, this is a change that you probably wouldn't want to make in practice, but I do want to give you a sense of just how complete these prompts can be. In other words, how far-reaching the changes are that you can make. So what I'm going to do is, instead of having the controls and the charts on the same page, I'm going to separate them off into 2 separate pages. So here we go. Change the Streamlit display so that it uses multiple pages. By the way, small errors, spelling mistakes don't matter, but I'm just being a little bit cautious here and correcting things. Change the Streamlit display so that it uses multiple pages. On the first tab shows an image representing the whole program. Go get the image. The second tab is the controls. The third tab is the charts. And the fourth, I did say tab. Shouldn't have said tab. I should have said page. The first page, I'm sorry, I need to correct that. Third. Fourth page is all about the app. Now, that's what I entered was not entirely grammatically correct. You can see that I made several errors, but as part of this prompt process, it's going through checking. It's doing a revision of my prompt. It's creating a better internal version, and it's going away to create that as we speak. Now, this is a fairly major re-architecting of this system. We're going from a single page display to a multiple page display, and that means generating a lot more code. It's going to generate one Python file per page, following the Streamlit way of doing things. Now, that's a large-scale change, which we've done through just a fairly straightforward prompt. And it's going to take a little while for it to go at and actually build all this. So you can see that it's going through an analysis process, looking at what I've got, trying to figure out what it's doing, generating an image. Well, I thought that would be a little bit of a fun thing to do. Maybe that was a mistake. But we'll just let it run and see what happens. So this is the process. You go through, you change, you prompt, you see how the system runs, and so on and so on and so on. Okay. And when this runs, what I'll do is I'll show you how it runs and see how we can interact with it. The important point is that if we wanted a multi-page app, that's one of the things that we should have asked it to do right from the start, but we didn't. As we were going through this cycle, we realized later that we wanted to go and have a multi-page app. Now, the downside of doing this is that we can end up with spaghetti code. So what happens is we start off with one structure, and we're gradually incrementing stuff, making changes to it, and we could go into a state where the code becomes unmaintainable because we didn't follow a coherent path. And that's typically what you see sometimes in large-scale legacy systems, right? They started off with one architecture, and over time, cumulative changes just makes the code harder and harder to understand, and the architecture differs considerably from where it would be if you were starting the system from scratch. So this is one of the problems with this kind of prompt iteration cycle right? Just go round and round and round. You can sometimes end up with a very, very suboptimal structure. And what we're going to do in the next section is talk about what you can do to avoid that. Now, we'll just let this go ahead and go and generate the code. It is generating the full multi-page app right now, as you can see on the screen. And we'll just wait for this to finish. And once again, you can see that the code it's producing, it seems to be, as it appearing on the screen, fairly reasonable. It is actually occasionally inserting some comments. It is following some rules about the way in which code is laid out. Layout's good, the variable names are good, the documentation is mostly good as well. And if it's going, building the multi-page system. And again, as I said, this is one of the problems with this process, right? It does take a while to execute. You can speed things up a little bit by choosing other code generation engines, but there are cost implications. And as somebody asked me, and the audience asked me, what version of Cursor am I using? I'm using the $20 a month version. Now, Cursor will give you a number of tokens free to get started, so there is a free tier to get started, but my experience has been that you burn through the free tokens very quickly. Certainly I found that the allocation of free tokens wasn't enough to get me to successfully build my first apps. So I'm afraid if you really want to play with this, you're going to have to spend $20 a month. Now, realistically, that's probably not a big deal given the importance of this technology and given the power of it. So if you think about it, you might spend $20 on a pizza or a couple of beers or whatever. This is the equivalent, and it will probably have many more positive effects for you on your career than these things. So we'll let this run. It's removing some dead code. It's doing a number of changes. Okay. All right, I'm going to let this go, right? And we'll come back to this in a second. Oh, has it actually finished? Okay, no, it's queued. It's going to take a little bit more time to run. So, look, a couple of things. As you go through this prompt iteration cycle, prompt to build, prompt to test, and so on, I'm going to give you a huge warning. You need to know, oh, there we go. Finally, it's run. There we go. Look, there's a controls tab, a charts tab, and an about tab. So it has done it, but look, this architectural change that I asked it to make took some time, especially because I asked it to insert an image, which is just created there. That's what took the long time. So just be careful as you do this about how you spend your time. Now, as you work with Cursor and you work with code generation, I want to give you a huge warning, right? You need to know the languages that you're generating code for. You need to learn, if you're generating Python, you need to know Python. If you're generating JavaScript, you need to know JavaScript. And in this case, I know Streamlit. So I knew what it was generating and I knew how it was doing it, right? So just be careful of that. So it's like driving a car. If you know how to drive, you can safely hit the accelerator to get you to where you want to go. If you don't know how to drive and you hit the accelerator, you're going to crash. And it's the same thing here. But before we move on, just pause for a second. Right, here's what we've done. We've put a UI on a notebook in less than 10 minutes. Even with all that prompt iteration that I've done here, even with asking for images, even for that big change that I made, it still took less than 10 minutes. Right, so it seems, to quote the Lego movie, everything is awesome, right? It seems that absolutely everything is wonderful here. But the reality is not so fast, right? So imagine that we have a larger project of 10, 100, or even 1,000 files or more. What if this process gave us a bad code structure at the start? then we would be iterating on poor foundations, which would more or less guarantee that we ended up with spaghetti code. We would be digging a bigger hole for ourselves as we went along. Each prompt would dig us deeper and deeper and deeper into the hole. And that can be a big problem for larger projects. So let me pull back a little second and tell you a joke, right? So it's not a very funny joke, but I think it illustrates the point here nicely. So there is an American who's visiting Dublin in Ireland, and he's a bit lost, and he wants the post office. So he stops this old lady on the streets and asks her, excuse me, can you tell me where the post office is? And this little old lady sits and she thinks for a minute, and she just thinks about where the post office are and where they are now. And after a moment or two of thinking, she says to the American, well, if I were you, I wouldn't start from here. Now, that old lady could be my mum because she's Irish, okay? But just taking the old lady's advice, taking my mother's advice here, what we would like to do is to do a little bit more planning, a little bit more detail and structure up front, and have more thinking and less thrashing. And that's what we're going to do next. All right, so plan mode is all about starting from a better place. It is a prompt to build a prompt. You give, in the prompt box that we've been using on the right-hand side, you give it a prompt, the engine thinks about it, researches, maybe asks you some questions, and it will build its own prompt to generate code. Now, why is this good? Because you can see details of what it is planning to generate. You can spot errors, you can spot missing pieces, and you can build a better architecture before even a single line of code has been written. So I am going to show you this working via an example. So just bear with me a minute while I open the correct folder and get this going. The reason why I'm going to do that, get it going first, is because sometimes the code generation, in this case prompt generation, can take a little bit more time. So I'm going to open that. It's a new project. As I said, I'm going to zero out the window to make sure that we've got a new prompt window, so the context is empty. Here I've got the prompt, and I'm going to paste it in, and I'm going to use plan mode. Now that's going to take a little while to go and generate a prompt on the screen, so I'm going to set that going right now. So let me explain what it is I'm doing and why. Now, I know here we are in Cambridge, and I know that many of you got the T to come here. You may well have got the subway to come here. And I'm going to build for you, in front of you, an interactive map of the MBTA, which is the Massachusetts Bay Transit Authority. It is going to use their API, and it is going to create a map of the MBTA T stations. It is going to have an interactive map. It will show a street map of Boston. It will use Python and JavaScript, and it will show you when the next train is due at any particular station. Now, I will read out the prompt in a second, but just before I do, how long do you think it would take you to build a system like this? Now, would it take you 2 or 3 days, 2 or 3 hours, or do you think you can do it in 20 minutes or less? So this code, this approach, by prompting a prompt, we will be able to build this entire system in 20 minutes or less. Now, bear in mind that your management will have seen demonstrations like this, and it will be setting their expectations. So let's go and have a look at the prompt, which is on the screen. There's a thing here that says, role, you're an expert Python JavaScript programmer. As somebody in the audience said to me, I don't think you need this, but it's just left it there. There are frameworks for building prompts. I think really they're not really very important. I think you can just more or less create this freestyle, right? It would be okay. But for now, that's the role. It says, the task is create for me an app that shows me the arrival times of the next Boston MBTA subway trains for a selected subway station. There will be 3 tabs: subway train times, system map, and about. On the subway train times tab, the user will be shown a map of the Boston area and a drop-down box showing the names of the subway lines. When the user selects a line, the line will be drawn on the screen using the color of the line. The station name will be shown. The predicted arrival time of the next train will be shown when the user hovers their mouse over a station. On the System Map tab, it will show a map of the subway system, and the About tab will show the author name. Now here's some of the constraints. Is it will use the code in the MBTA folder, and it will use that to access the API. Now this is a little bit of a cheat, and I will explain why it's cheating a bit later. Now, as it'll build the prompt. It's going to take a while to do it. When it does build the prompt, it will actually appear on the screen. So here we go. Oh, there we go. So this is what it's planning to build. Let me make this screen a little bit bigger so we can see everything. It's telling me what it wants to build. Now, this has actually told me it will use a fast API backend, but I think this is okay. Front end vanilla JavaScript only. Yeah, that seems to be okay. Let me ensure the JavaScript is well commented. I have had some problems in the past with it not commenting the JavaScript well enough. So it's going to make some changes to the prompt, which we'll see on the screen. Nope. Okay, let me just get rid of this. Now, let's add a virtual environment and make sure it uses a virtual environment for the Python side of this project. Now, it should have already done that. It was in the specification that I gave, but it didn't make it to the prompt. I've checked behind the scenes and it actually isn't here. So now I've typed this in and I'm going to hit return. And what's going to happen is my prompt on the screen is going to be updated to reflect this need to generate a virtual environment for the Python files. Now that's going to take a little while it thinks about that. It's going to update the plan that's in front of us. It's going to insert the need for a virtual environment into the plan, as we can see here on the right hand side. And when that's complete, we'll be able to build the software. Now I'm just going to give this a second or two to finish up. It's planning the next moves. There we go. And it's summarized. There we go. Okay, so now we can start to build the app. But what I'm going to do is just briefly step through the prompt as it stands for right now. I've made several changes to it. It is quite detailed. The more detailed the prompt, of course, the longer it will take to go and construct it. So there we go, order of implementation, and there's a whole set of to-dos. Now I'm going to click on the build, and it will go away, and it will build the system. Now this is going to take some time to build, and we do need to keep our eye on it to make sure that it doesn't do anything foolish. Now while it's actually going away and building the system, there's some things I need to tell you. I did cheat slightly with this, and it's a cheat that you're going to need to do as well. Let's go back to the MBTA API because there's a problem with it, and it's a problem that other APIs also have too, and other people's code has. The MBTA API is great. It actually does what it needs to do. It will give you the data. The servers are very reliable, etc., etc. But there are some problems with it. One of the problems is that it's not very well documented. So what that means is when the code comes to generate, what happens is the AI is looking at the documentation and trying to figure out what it needs to do to build the system. But if the document isn't great, that means that the API, the AI can't reason very well. The other issue is that there are not very many good examples online of people using this API to build apps. Now, perhaps if we were in New York or London or somewhere else with a large subway system, that wouldn't be the case. But it is true in Boston that there are not many apps built upon the MBTA API. What that means is that the AI in Cursor doesn't have a lot to go on when it's in terms of building these apps for us. So that's another problem. The other problem is that the API isn't complete, meaning that there are some undocumented things that you have to do to get the whole system to work. Now, I'm not going to go into what they are. They're not that difficult, but they are some things that you have to do. Now, what I did in order to make this work is I used the API to pull in the data, and I wrote an MBTA class in Python to wrapper the JavaScript API. And what I did is I corrected for all of the problems. I've got some example code that shows how you use the API, and there's enough documentation in terms of what I produced, right, for this AI engine, for the Cursor AI engine, to be able to reason about the API and create a model based on it. So let me summarize this. The MBTA documentation and the MBTA API wasn't very well documented. Trying to build an app on top of that is not a good idea. So when you don't have well documented code, the best thing for you to do is to document it, create some examples, and then ask the Cursor AI to build on top of it. And that's what I did. Okay? That's really important that you understand that. There are people in Boston, many people in Boston working for startups who know this. So when they are building code and they want their AI to build on top of it, they need to make sure that that code is very well documented and that there are examples of its use, and that the code itself has lots of comments explaining how it uses, how it's to be used. That's the way that they can build on top of it, successfully build on top of it apps. So if your code isn't very well documented, CodeGen is not going to work well for you. Now, this is working its way through the code generation process. Here we go. It says there are 7 to-dos. It's now on the 3rd. What it's doing is it's going to build up the vanilla JavaScript front end. It's then going to build me the fast API backend. It's going to do a little bit of checking to make sure that data is correctly passed between the front end and the back end. And it's working its way through the specification, as you can see here, just step by step. Now, this is going to take a little while to do. Now, my guess is that this is probably 3 or 4 minutes of runtime, right, to generate the code. If you have large-scale code that you're trying to generate, maybe generating multiple files, what you might want to do is to investigate using the Cursor CLI and do that offline. So in other words, what you do is you create a script, maybe a bash type script, where it can go and run and create the code that you want to do. Now that takes us close to the idea of the so-called Ralph loops and other more advanced usages of the Cursor API, and that will be in Sebastian's talk after the break. So stay tuned for that. Now just give us a minute while this thing is constructing. It's going to take a little while to build. So what I'll do is I'll pause the recording here and then come back when it's actually constructed the code. Now we're coming back about a minute later and it's finished the build. It's actually done a little bit of internal testing and now it's started the app. So it's telling me if I go to this URL, I should be able to see the system. So I'm going to open the browser. So this is a browser that's built into the into Cursor. And let me paste in the URL that it's given me. Oh, okay. So this looks as if it's actually managed to build something. So let's have a look. Let's select a line. Let's select, well, the red line goes through here. So let's select the red line. Okay. And that looks like it's the red line indeed. Let me zoom in correctly. It's giving me some warnings at the bottom. Let's select another line, the orange line. Okay. That looks correct. Now, I asked it in the instructions to give me station indicators, which are little white circles, and it's given me instead orange, and as you saw before, a red for the red line. But let's click on one of these things. Oh, and it is actually telling me the train times, the next expected train times. And I'll go click down here. We'll see, no predictions. Okay, so that one needs to be fixed. But you can see here that mostly it works. Okay, so there are some issues. It's not quite got everything that we want. Okay, there we go. It's loading. So let me have a look at the green line. Okay, well, that looks okay too. And there are the train times. So you can see that there are some things that we have to do here. So what we might want to do is shift the pop-up so that it actually appears in the screen completely. oh, we might want to change this so that instead of being solid green, solid orange, solid red, they're actually circles. And so on. There are a number of small changes that we can make, but I won't fret that. Let's have a look at the system map. Well, this looks like a correct system map. It's missed out the Matapan trolley, but we can correct that. And if I click on these lines, it's giving me the station names. So I'm going to make a little change to this. I'm going to ask it to give me the station facilities when I click on each of the stations. So here's the prompt. On the System Map tab, give me the station facilities when I click on a station. Now, this is a variation of the process that I showed you before. So the process I showed you before with the COVID app was we prompted, got something on the screen, re-prompted, got something on the screen, and re-prompted. And what we're doing here, well, we've kind of moved almost all of that work to the prompt. We've kind of iterated on the prompt to make sure it's okay. And that's got us almost all of the way there. But there's still some bits and pieces that we have to do here from the command line to finish it off. And I'm just going to show you one of these things now. And then what we'll do is rebuild the, restart the app so you can see it taking place. So even with the prompt to build the prompt, there's still some incremental changes that we have to make. So I'll just let that construct itself and rebuild, and then we'll restart the app in a second. Okay, so let's restart. Now, a lot of the time you don't have to restart and it will handle that automatically. But for demonstration purposes here, I'm showing you that you can restart the app and this is how that you can do it. So it will bring the server down, it will stop it as we'll see in the terminal window at the bottom, then it will restart it again. So we'll be able to see whether my prompt actually worked and whether it will actually give us the facilities at the station or not. So what happens now is it's going to restart. Okay, let's try again. Let's do system map. Okay, there we go. So in this case, it's actually telling me what the facilities are, and that's based on data that I've downloaded from the MBTA. Now, we could go on for this and iterate and fix a lot of these other issues on this app, but I think you can see where we've got to. So even with plan mode, we need iterative development. Our little old Irish lady was mostly correct, right? If you start from a better place, you can get to where you want to go to faster. So you use plan mode when you want the system to think a bit more. Now, here's some things to bear in mind. Sometimes prompting just doesn't work, right? And that's why I had to go and create the MBTA wrapper, because I found just by sitting there and prompting, it doesn't work. Sometimes it gets itself stuck in a rut and you have to go back to the start and restart with a whole construction process. Sometimes it just gets things wrong and ignores your instructions. Now, despite all of those things, despite all of those issues, it is still faster for you to use code generation than not. Your productivity as a developer is multiplied by this kind of thing. Now, what is the implications of code generation for you and your career? And this reminds me of a joke, and it's a joke about it's a German joke, and the idea is that there's a German householder and their washing machine breaks down. So they call out the washing machine repairman. And in he comes, he twiddles his very Germanic moustache. He looks at the washing machine, holds it, listens to it a bit, thinks for a second, takes a step back, and very, very carefully gives it a big kick in a very specific location of the washing machine. Suddenly the washing machine bursts into life and the problem is solved, and the householder is absolutely delighted. So the washing machine man writes out a ticket, writes out the bill, and it's a bill for 200 euros. The householder absolutely explodes in fury and says, 200 euros for kicking a washing machine? That's outrageous. So the washing machine man stops, thinks, he tears up the bill and rewrites it. And he says, for kicking the washing machine, €1. for knowing where to kick the washing machine, €199. And that, ladies and gentlemen, is where we are right now. We know where to kick the washing machine to make this work. That's our point of differentiation, right? You can't just go and kick this thing anywhere. It's really all about knowing how to get it to work in the right place, knowing how Python works, knowing how JavaScript works, knowing all of these things so you can kick this washing machine in the correct place. Now, some summary before the break. Cursor is a productivity supercharger. You can get things done incredibly quickly. We can build a UI on a notebook in 3.5 minutes. We can build an MBTA app in 15 minutes. Others in your organization will know what this tech means, and it will be setting their expectations of your productivity. But I have to tell you, it is not a magic wand, and you have to use this technology thoughtfully and carefully. After the break, ladies and gentlemen, we'll be coming back and Sebastian will be talking about rules, the end game, and other more advanced issues. Thank you.